as a year ago, turn on my timer. Thank you for joining us today. Good afternoon, guys. My name is Jay, and I'm the senior head at IA Group. So here is IA. And today I'm going to talk about LLMs. And can I ask a favor? Can you raise your hand if you use any large language model? Today, just recently, yeah, almost everyone. ChatGPT, Gemma, so just welcome to the IA office and IEA. Request thanking IEA to talk about it. And our mission is to change the way the world experiences property. But I'm not going to spend the whole talk about IEA. Okay, let's move on. And but let's have a look how can we use LLM to improve our property experience. So let me introduce you Ruby. So have a look. Ruby, she's 35 years old, and she has 2 kids, and she's looking for a property. So under about $700,000. Because she has 2 kids, so good public school, good anything. And how can we use LLMs to improve Ruby's property seeking experience? So today, we are going to use a large language model called Gemma because there's a Google event. So otherwise, I use that. And remove that piece. And so to use a Gemma large language model, so we need to do some coding for setup. Actually, we are doing live coding, so if I some mistake. But let's give it a go and see how it goes. So I started notebook. So if you use if you do machine learning before or you use Python before, you probably notice that you notebook. So you can run your Python code on the web page. Technically, they have a kind of running in the background. And hopefully they can run very access setup in one. And so the spinner is running, and I hope it can run because I don't know. Come on, you know, and but while we're waiting, and I'd like to actually start. So as you can see here, the small number 1 here. So it means we finished executing that installation. So we download some packages. The most important part is called a curves, which is a library to use different large language models, particularly for open models. So some proprietary models like ChatGPT 4 is this tool, but any open models they can available. And that's very easy. As you can see, we download packages and we do a little bit setting here, so you can see. You don't have to understand that. I copied that from online. But technically, I find it fine. And technically, so Keras is a Google product. They provide different backends. For example, nowadays popular backends, and as you can see, it's like here Keras backends, right? So you can see my present hopefully because Zoom doesn't work well with scary. And so I just highlight it. So they have Jets, they have PyTorch, or they have so I don't know why they just recommend use Jets. I use Jets for the case, but that's from the official website from Gemma. So I already set it up, and then as you can see, Jets is using the GPU. So if you use machine learning, and you might heard about GPU, and it means we can use GPU to speed up our machine learning training process. So as you can see here, if you don't see GPU, just over there and click on it, and then you can see GPU. You can use GPU. So I already used some of the notebook in the open platform. For example, I'm using Cargo, also Google's product, and then as you can see here, Cargo. So they give us a free GPU usage for 40 hours. So more than enough because you don't work 40 hours free, right? If you do, just try to apply. And alrighty, so you can see we can turn on the GPU, but if you don't turn on the GPU, it takes forever to run this model. Forever means forever. And so now we already configured the model, and we're going to run. Okay, I can just close this part, and I'm going to load the model. So technically, if I open up this bar again, you can see the GPU start going up. because we loaded the entire model, all the parameters into the memory, the GPU memory. You can see, boom, this 15 gigabyte memory using it. So while we're waiting it, because we're using the free account, I think Google, you heard, you pay a free, and using a free account. So let's spend some time while we're waiting to look at how actually LLMs operates. Okay, so to make it easier to understand, and I'm going to use because I can't find equivalent tool on Google platform. Sorry about that. So I use OpenAI. And if you look at this one, so I actually send this message today and ask OpenAI GPT 3.5 model to generate some words. Okay, I hit the submit button. And hopefully it works. Okay, it does. It does work, and you can see they generate word by word. So how a large language model works? Actually, they word and write is predict the next word, or more precisely, they predict next token. So this one, if you look in the whole word over any wording, for example, this one here, Melbourne, and then it gives you the probability of the distribution. So when they generate GDG and next token, probably they generate Melbourne because they have a higher probability. More than 80% of probability they generate Melbourne, so they change, they actually give Melbourne. So as they continued on, you can see they continue to generate these words based on the probabilities. So if we change the temperature here, and it actually can change the way they generate. For example, in a higher temperature, I put it 2 just for fun, okay, just for fun. And then I regenerate again. I just click clear and then regenerate again. You might see some randomness because too creative. So, and then you can see they just stop generating because they don't know what to do, right? What to do? They can't. So, and I just better to bring back to make it more sense, right? So it's around 80%, something like that. So I regenerate again, and I like to give you some more feedback. Okay, might be stuck now. Who cares? And then if I hold again, and then if you look at them, and they generate, they highlight them, they call tokens. And some of the word, they actually split into two different. So that's how large language model doesn't work with words. Make sure you understand that. Actually, it took me a while to understand. And they work with tokens. Tokens, if you learn numbers. Let's have a look what tokens look like. Okay, so if we switch to, I don't find Google, by the way, again. And I use the OpenAI one, it's called tokenizer. And so when you work with large language models, we better to understand the tokens. So for example, if I put a sentence here, actually incomplete sentence, panda is an NMR, not mode, because I put a typo there. But if you look at that, and the bottom part is a tokens. So as you can see here, the panda actually is a popular, very popular word, which I say split into two different tokens. The P and then enda. I have no idea how they work, but still, if you want to, you just apply to OpenAI and find out the algorithm. and here is the here and here. A token doesn't mean a word. So some words they have multiple tokens. And if you look at this one here, I put a very interesting example here. So as you can see, I can put a typo there. It's not animal, it's called animal. And if a different tokenizer, for example, GPT-4o and GPT-3.5, if you look at it carefully, and they have different tokenization process. The animal in older model, they split in two words, so two tokens, sorry. And then in the newer model, if you look at this part carefully, please, and then you look at that, they put one word or one token. So this is the way you understand tokens, and then we just move back to see that model get loaded or not. Okay, let's got that model loaded. So as you can see here, we go up the model, and I just print out the summary. And as you can see here, the summary is how this model looks like. And this model, I use 2.6 billion parameters here because I have 3 account then. And if I use a bigger model, and this GPU will fall. So technically I cannot do this talk. So I use the smallest model here, and it means they may not generate the best quality. But don't worry, actually I used this model for some of our product and actually worked very well. So that's why I chose that. It's not a big deal for Google event. And let's move on. And so you can see this is a 2.6 billion parameters large language model and very small these days, but if 2 years ago it's huge. It's much bigger than GPT-2, GPT, whatever older model. And then let's move on. And I think we are going to come back to our vision is how can we use an LLM to improve the property experience, right? So we are going to talk about four different techniques. So zero-shot query, and we set up the baseline for us. And we are going to move on to the prompt engineering, and then later on we go to something called rank, and then called Retrieval-Augmented Generation, and then last one we will go through the functioning. So you don't have to remember anything this year. We can just go through one by one. And let's start with something called zero-shot Q&A. So zero-shot Q&A. Before we go on, I like to actually run the code first because it takes a while. So I hit the button, and then you run, and then we just go and explain what's going on there. So okay, so zero-shot Q&A means we ask a question to an LLM without providing additional comments. So think about this 3-year kid. Right, so different model, like the people that have different options, 3-year-old kids or 30-year-old adult, assuming they might have more knowledge than 3-year-old kid. So that's the same thing. So when we ask the same question to different models and a more capable model, they can answer the question much better. So let's have a look and compare. So this is the answer from the Gemma 2 model, 2.6 billion parameters model, and it will give us some actually decent answer. It will give us something okay, and you can look at, for instance, something like that. But if I do this exactly same query to a much bigger model, which is GPT-4o model, so if I send the same query there, and they will provide much more detailed response. And the reason why is because the GPT-4 model has a much bigger pre-trained data, and they have a lot more parameters. I mentioned parameters a few times, and parameters, the bigger parameters is a much bigger neural network, and they have a bigger knowledge. So the Luma said, actually, OpenAI, they didn't tell us how much parameters in that model. If you want to, you find a job at me. But the Luma said, and they have 1.7 trillion parameters, almost 1,000 times as the German model we are using today. If you imagine 1,000 times a huge number of times, not 1,000 addition. So imagine there's a 3-year-old kid of 30-year-old adult, and he can put it this way, and most likely adult will answer some math question much better than 3-year-old kid. The same to the model. So if you have budget, you better to use the best model. But sometimes, for some constraints, for example, you don't have the budget, or you want to run your model on the device, then we have to run on small parameters model, which is Gemma 2. So let's come back to our talk. And are we able to? So the question is, are we able to? So there is the comparison. You see, there's much more details when we use a bigger model. But are we able to try to improve our Gemma 2 model to try to catch up on what GPT-4 can produce? So the next technique we are going to introduce is called prompt engineering. So prompt engineering, again, I try to run it again. And now run it first before I expand it, because it takes time. And okay, we're running it, and then I'm going to expand view and prompt engineering. So that's the name implies engineer, right? So it's something doing something in your prompt. Technically, just you craft or write a better prompt to interact with your model. That's it. So in our case, we provide 2 small improvements here. One is we're providing bias profile. So we give the large language model more context, more details. And second, we ask, okay, I'm going to close this one here. And activity, and we are asking the model to add this role. For example, in this case, we ask them to be, can you be an AI assistant, and particularly in Australian property market. And once we do those two small setups, and the model it can produce a decent improvement. For example, they give us some of the subjects, and this time each recommendation with pros and cons. So as you can see here, they grade IS and Q, right? So they're pretty good suburb, but I believe I could not buy them under $700,000 if I could, whatever. I like this brand level. And so think about this. How can we actually let the model understand more up-to-date data? Because they pretty much generate some data is not up-to-date. That's why they suggest something like Q. And so the next improvement or technique we are going to introduce. I'm going to introduce correct. So before we get into the RAG part, and then I'd like to ask, why do we need a RAG? Okay, imagine all the model I can say, okay, 99% models, and they get chained by quick chain data sets. Yeah. So with chain data sets, usually not up to date. Think about our property data, they update every day. So OpenAI cannot train the model every day and release the model. They train the model and then they do alignment. It takes a couple months, and then they release it and then a few months behind. So every time you use model, you always have a cut off storage data. So without a RAG, so with a RAG, we can actually try to retrieve some of the up-to-date data. For example, this data, or some of the proprietary data. Imagine this case, everyone they can access the best model in the world with a credit card. So like a ChatGPT or Gemini model or Claude model with a credit card. But not everyone can build a best AI integration solution because they don't have the data. For example, IA has all the property data. And then if you build a property app, better to marry IA data with the best LLM system, for example, GPT or Gemini together, so to build the best quality of the product. So that's why we have RAG here. So RAG works in 3 simple steps, very simple. The first one is called retrieval. So retrieval means we can find some relevant data from the data source. The data source could be your proprietary data database, or it could be something you build your own vector store. So vector store, we organize data not just by types, but also by meanings. But we don't go too far. So, and then once we get the relevant data, we plug it into your engineering prompt, which is argument. So this is the second part. So plug your data or your result into the prompt, and then use that integrated prompt, send it to the model and generate. That's it. That's the RAG. Super simple, 3 steps. And next, walk through how we can use RAG to improve our solution. So to improve our solution, and we are going to use up-to-date data because Google search engine, API costs my money, so I just try to avoid that. I use DuckDuckGo. and okay, so to use a search engine, basically everyone understands how search engine works, right? So you search the keyword and then they give you some up-to-date information, and you use the search engine. And currently, most of the traditional search engine they don't work well with natural languages. For example, you ask questions, they don't work. So they only work with search terms. So how can we convert the query into search terms? We can use the LLM as well. So the way we do is we also use a prompt and then ask it, can you convert the query into search terms? And then let's run it, and it takes a while, and then we convert Ruby's requirements or queries into search terms. It takes a while, not operate. Okay, yeah, here it is. So as you can see, we provide the contents and the query, and then we put it there. And the LLM, which is the Gemma 2, will give us a bunch of search terms here. So a few of them. Imagine if you're building AI search engine. That is the first step you go. if you build this, then you can get something like Complexity.ai and $1 billion wait. Take a photo and then you go home and do it right. And yeah, so that's true actually. So you just basically take the lecture language, natural language, and then convert it to search terms and search by different search engines and grab the results again. Okay, so because for the demonstration purpose, I only pick one. If you build a professor's AI, for example, similar like that, you better to figure out how many search terms you want and do different searches and put them back together and then get something. And so now we already have the search terms. And then let's use the search terms and go to the soft.go page and do a search. So as you can see, I only for the simplicity sake, I only did one search term. And that is how it comes back. It comes back like I don't know, it doesn't look like well, I'm doing it again. It doesn't show me any suburbs. Okay, now it's answering the suburbs. This is a big part. Okay, so as you can see, imagine if you do different search and then you find out that actually usable and up to date, then you can use that as a context. And remember the A part, right? The second part. We already finished the R, so we move the A part. So we set the search results into the context variable here, and then put it back into our engineering report. Here, experience, and then we use it as a full context to send to the engine or the model. Now we actually do it again. Give the model more up-to-date information and deliver information as well. So let's wait for me. Come on. Maybe 2 minutes. We still have okay. And Google, if you give me a pay patch. I hold it as a pro, otherwise I have backup plan. Don't worry. And this you can see here, actually it's almost our limit, 16 gigabytes. And come on, you can do it. But while we're waiting, and I just okay, actually done. That's how I keep hearing. And as you can see here, we send out this part is what we send to the model. So compared with the engineering, the prompt engineering part, the only difference is we plug in the context, which what we got from search engine. After we got it from search engine, and then they couldn't recommend Q or something like a super expensive subject to me anymore or Ruby, and they give us more reasonable recommendation, reasonable part. Get it from the search engine. So you think about your red part is also important. If you have much more accurate, up-to-date information, for example, you get all the information from IEA, you probably get a better recommendation as well. So not just from DuckDuckGo and random search. So as you can see, red is very important. So Google noticed that they actually released something called data Gemma just last month, actually 2 weeks ago, and they use the data Gemma to allow us to use those data points, like we see the 240 billion data points, and to use up-to-date information. And if you like, you can check it out. I will open source this notebook as well. And you can check it out, and they are using the Gemma model is same as what we are talking about today. So as you can see, small model with a data set, and they can do a lot. And let's move on to the last bit. So because we only have 5 minutes to go, and we are going to move a little bit forward. So we get up-to-date information, but we like to have something called personalization. So think about small model, it works very well with your device, like this Google device, iOS device, and particularly running on your device. And so in this case, they can provide personalization for the user and running locally. So let's have a look how they actually improve personalization on those devices. They call it functioning. So functioning with LoRa means low rank, the low rank on the patient. And don't worry about the term, I don't even know. But I can do it anyway. And then what that means. So technically, you probably heard something called Edge AI. Technically, Edge AI is a LLM or AI system or AI model running on your own device. It's like this one here. And they don't need a cloud, they don't need a GPU. I mean, they have GPU on the device, but not GPU like from the cargo or something. And they can provide a lot of benefit. For example, personalization, privacy, because your data never leave your device, and they will respond very quickly because they don't need a network. Very efficient as well, something like that. So let's go through because they're so useful. So that's why we're talking about here. And as you can see, Apple and Google, they are actively using this technique on their Edge AI. And let's have a look how Apple intelligence work. So as you can see, I put two diagrams there. One is for Apple, one is for Google, and they work almost very similar ways. And let's have a look at Apple Intelligence first. So Apple Intelligence, they provide free training foundational model. Free training, if you look at our model, is 2.6, very similar size. They have a free training model, and they said that they work better than some of the GPT providers or something like that. They say they, but don't worry. So small model, but I'm curious how. So the way they do that is they use some fine-tuned adapters. So as you can see here, Apple provides more than 10 different adapters on top of that very small foundational model. In some tasks, they can actually work even better than GPT 3.5. So that's why we're doing here, and how can we actually improve a small model and work completely with a big model. So how these adapters work? They are using the ways what we are doing today, using LoRa functioning. And you look at the 3D foundational model, if you load up in your device, it probably will use similar GPU. This one here, 15 gigabyte. But those adapters only cost about 10 megabytes to 20 megabytes. It's very small. You think about comparing with gigabytes. And if they have 10, 20, and they don't have to run every time. So they open the mail app, they only run the mail response adapters. So only extra 20 megabytes memory on top of that for something. And of course, memory doesn't mean parameters, but I just make it sense. And it means you add on a little bit tiny memory, and then you get a very good quality of the generation using this technique. So let's move on. And the Android OS, which is I'm having here, I have the Gemma on my device as well. They're using very similar techniques. Eventually, Apple or Google, they allow us to develop all these adapters and then plug it in your app. And when you run the app, so you can use the foundational model on Apple Intelligence or Gemini Nano. Then using your adapter to perform some of the AI capabilities. For example, email, Drive, whatever. You can use your image page with your app. So let's have a look how can we actually use it. How can we do the functioning? So before we do a functioning, and then we need to prepare some data. In our case, we try to improve the personalization. So we prepare all the data, particularly for Ruby. So because we are doing demonstration here, so I need to prepare 3 records, very tiny. But don't worry, Apple said they are adapted only about 800. 800 records can improve significantly for the quality. So 3 is something, right? So just for that coverage. And now I prepare the data. It's done. Yes, and then let's turn on the function. So as you can see, I have 2 commands here. One is before, one's after we turn on. And let's have a look together. So before we turn on, we saw it before, and we have 2.6 billion trainable parameters. And once we turn it on, and those parameters will shift to non-trainable. So LoRa functioning, actually, we will not touch any existing parameters. And we only add on, which is trainable parameters, as you can see here, 2.9 million. See, compared with the bottom part, it's very small, but it's good enough. If you think about what Apple or Google data they did, and those adapters very small, but very usable, very effective. So we are doing the same as well here, and then we are going to do some settings, and I don't understand them. Again, I copy from there. I try to understand anyway. And but the last thing is most important is copy. So it means that's how we fine tune our model. So let's run it, and it takes a while, but it takes about a minute. So 5 minutes, 1 minute should be okay. And then okay, come on, you can do it. And so I just explained to you, fit function means they are doing fine tuning, and if you know machine learning, and they're actually doing some what's it called, finding the loop or something like that. I don't want to go too deep because I don't know. But after that, your model will add on extra parameters. Remember that extra parameters, tunable parameters. It means we change the behavior of our model. And if after that, if we run this query again with the same model, now, okay, come on, I'm still running the function. Come on, you can do it. I only 3 minutes left. Google, give me a pair. Okay, come on. Almost there. If you see a progress bar and then the fine tuning, and I used to fine tune like a 10,000 records and it's about a day, but this only 3 records, so it's about 1 minute. But Google, give me a pair. To finish my talk on time. Okay. They have some memory issue now. Come on. They actually broke. If they do, and then I just they're still running. Sorry. Six finger. Okay, then they finished. Sorry. And they actually ran out of memory. I cannot demonstrate, but imagine I run this functioning stuff again and give me another one. Google. And I prepare if I broke, so this is what I had. And it go there back here functioning if I finish functioning, for example, and if I finish functioning, and then it will generate much more personalized message, which is the improvement after the function. And also, we will still have relevant information, which is function before. And if you put them all compare each other, and that's what we go through. We are catching up or closer to the original 4.40 engine. And pretty much that's it today. And we walk through 4 different techniques. But we can even do better, actually, a lot. We can do better, and we can have a better data set. We can use the data Gemma, and nowadays very popular. We should use action workflow. That's what I did another talk in the IEA before. And if you like the talk, and give me a sec, I need to actually, if you like the talk, you can actually get this little book. But before I need to publish it. Okay, this is a release. And hopefully that's published. Otherwise, you brand Google or Google. And so this is standard. You probably get a notebook. You can play around yourself, and I better to shut up. Thank you for your time.
Thank you, Jake. We might have time for one question. Anyone? Two?
I love
People okay first.
Thank you for your talking, and I just wondering, like, you say you will improve if you have better data sets.
Yes.
And just wondering how you know the output of the, how which large language model is better. Like, you can't read each single line of the output, and to consider you consider that data set is more suitable. Is any like way or measure to validate to notice that you apply some statistics good enough?
Very good question. I think that's a very common challenge we're facing. So it's not only apply for data set, it's more about apply to your whole solution. So we have innovation process. When we do project, we actually doing the same query again and again to different configuration, different model, different data set, and then sometimes we use model to check models. And then sometimes we use human, we call human feedback. So human reinforcement feedback to check the output. So, but of course, we use model to check first at the same time. And yeah.
If you have expertise to validate output, so it's just like
Yeah, so doing a project at production environment, we don't only have AI experts or developers, we also have domain specialists. So those domain specialists actually can look at their query, their output, and then they compare what they actually want. So humans still make the final call, which is called alignment. So that we do those processes as well, evaluation. So on all the projects. And so as a developer, of course, you have some principles how you dig the data, the feature engineering. So you have your idea how to dig the data and prepare a good set of data.
Yeah, thank you.
No worries. Thank you guys.